So we're finally to the end of our 3-week unit on bonding. And the last thing we want to talk about is how polarity, a molecule being polar or nonpolar, will affect its shape and therefore function. And so one thing you did earlier in the lab was put drops of water onto a simulated penny. And how did you get so many drops of water on the penny? Maybe you've done this in real life in a science class. I think I had one kid get 70 drops one time. So how is that possible? Well, it has to do with water being polar, right? Every water molecule has a partially positively charged pole, an end that has a positive charge, that's where the hydrogens are, and it has a partially negatively charged pole, and that's the opposite side where the oxygen is. And so we never only have one water molecule hanging out. In any sample of water, you're going to have Avogadro's number of water molecules. And so they're going to arrange themselves so that the partially positive side of one is connecting to the partially negative side of another. And that's going to help them pack more tightly together, which is going to allow you to have this surface tension or this cohesion, right? And we can see this in this simulation. I'll link you to it if you like. Let's slow it down a little bit. So maybe not that slow. And see those charges so that you can actually see the way the water molecules arrange. So are going to form these really temporary interactions, not as strong as real bonds, but intermolecular forces between molecules called hydrogen bonds. And that's between the partially charged hydrogen of one atom and the partially negatively charged oxygen of another. So water's polarity enables these properties like surface tension, cohesion, adhesion. And it also enables its solubility, what water can dissolve or not, right? So perhaps you've heard the phrase like dissolves like. And what that means is that water can dissolve other polar molecules and ions, so things with charges. Water cannot dissolve nonpolar molecules. And so here's an example of an ionic compound, sodium chloride. And when water is introduced to it, the water is not only going to dissolve the salt, it's actually going to have the ions dissociate. And that's because watch the partially positively charged hydrogens in white are going to surround the negative chlorine in purple. And watch the partially negatively charged oxygen in red is going to surround the positively charged sodium in green. And so this is why water can dissolve any salts or other polar molecules. Anything with even just a partial charge, water can dissolve. But water cannot dissolve nonpolar molecules. And so I'll link you to this simulation as well. Water is so attracted to itself because of its partial charges, that it has no attraction for anything that's nonpolar, anything that doesn't have any difference in electronegativity, like hydrocarbons. So the water is going to stay attracted to itself, even if we shake it up and make the oil and water mix. The water is going to go back to being isolated together, and the oil or hydrocarbon will go back to being isolated together, because water is polar, and so it's attracted to itself and other charged or partially charged molecules. All right, so we're wrapping up this week. The last thing we want to tackle is some optional assignments. So there's labs there for you to try if you have at-home equipment. Just rubbing alcohol and collecting leaves. There's one about what drugs do to the brain and the molecular shape of drugs. There's a lot of different activities I pulled for you to choose one. Try to pick at least one to try. Make sure you finish up your capture sheet. The week 3 capture sheet has some